All right. Hello, fellow YouTubians. This is Terry Andrews Jr., otherwise known as the J5 Guru. Okay, so this video is going to be about the lip lights and some questions that have been raised, the lip lights and the driver board. Some questions that have been raised by a few people, most recently Chris Wright over in the UK that actually purchased a set of lip light PCBs from me. He had some questions, and over the years other people have kind of had the same questions, so I kind of figured I'd clarify some things, and I will put this out there. I actually designed this circuit back in 2009, so my memory's a little bit fuzzy, and my electronic skills, yeah, I'm not an electronics designer or engineer. This is something I kind of found some things on the internet and kind of adapted and you know, experimented and tested and prototyped until I got something that worked and did what I wanted it to do. It actually took me about 3 months because yeah, I had to learn this stuff on the fly. Had to teach myself what I needed to know to get to the end result. So, okay, first of all, as far as people are saying, you know, where do the parts go? How are they oriented? Things like that. Everything's in the PDF, and all of the, let me see here, focus. All of the PCBs are silk screened with the proper orientation. Like you'll notice up here. Oops, wrong one. Okay. You notice how the flat of the LED, how the flats alternate on these two end ones here. Okay, that's because the LED out here, the flat needs to be on this side, so the LED physically did not stick past the circuit board. The same thing on this side. All these LEDs are wired in series. There are a total of 21, I believe, if memory serves me correctly. Or is that 19? I guess 19. Huh, thought it was 21. 19 different inputs. And they are all numbered. Come on, focus. Focus. There we go. You can see how they're all numbered from 1 through 19. Okay. Double-sided PCB, plated through holes. These were professionally made. We had 50 sets of these made. Okay. And these dimensionally are identical to the original ones that were in the original robot. So they fit, and we put in mounting points. The original robot, they were actually just double-sided taped to the structure. We actually put in proper plated through holes for standoffs to properly bolt them to the structure. This is the driver board PCB. Again, come on, focus, focus. Come on. Don't do this to me. High quality production here, folks. Hold on, I got to pull up my autofocus thing here. That's about right. So as you can see, everything is silk screened, so you know the orientation and the exact placement of all the parts. Okay, you'll notice up here that there are a variety of holes. Okay, again, I was, I wanted to make sure you could use whatever kind of potentiometer you wanted and orient it in whatever position you wanted. That's why there are the extra provided holes in there. You'll see in this particular application, 6 of the holes are not even used. Okay. This is how all the parts go in there. Uh, 20-volt regulator here. Indicator LED here. There are on the back side 2 added capacitors. I'll get into that in a second, why they're on the back and was not incorporated into the actual board. Okay. And everything is labeled, let me see here. like the resistors. Whoops, got it upside down. You can see the resistor values are all in there. I can see 360, 560, 560, 750, 560, 750. Okay, so turn my autofocus back on. So as I've already said, I'm not an expert on these things, okay, on electronics. So this requires 24 volt input. This is what I believe it's a color organ, and the implementation is basically, I believe it's what's referred to as a diode ladder, where you take an input voltage. Let me see. Boy, it's been so long since I worked on it. Okay, so I take an input voltage to the first diode. Okay, once that voltage goes above, I believe it's 0.63 volts, it starts conducting current. Once that current starts conducting, it turns on this transistor, this first transistor, which then gives voltage to the LED, the first LED string, which I believe is actually the two red ones, is the first. So it lights up the first two LEDs. And then once it goes, once the voltage goes, the input voltage goes to, it would be 1.26 volts, the second transistor turns on, and so on and so forth, all the way up to 3.23 volts. Actually, or no, sorry, that's wrong. It's 13.23. It's actually wrong because I calculated it. So it's actually 0.63 times 19, not 21, 11.97. Okay, so at 11.97 volts, all of the lights come on. All of the transistors have turned on. And at the front end of it is a simple, is a way to take your audio input signal and transform that AC audio input into a DC voltage out here, corresponding adjustable by the potentiometers, by the signal and gain potentiometers. You adjust those two so that when you have no noise, no LEDs are, no volume, no LEDs are lit. And when you have maximum volume, the very last set of LEDs momentarily blink. Okay, and this gives it that really cool, you'll see it in my other videos, that really cool, color organ effect. So this is the populated with the LEDs, populated PCB with the LEDs, okay, and the connecting cable. And again, this is keyed in, so you can't screw it up. You just plug it in like this. The key's in there, you push it in. Pretty simple. Two power wires, 24 volts in, and then your two audio input, your signal and ground for your audio input into this connector. Now, I will say, the design's not perfect. For some reason, it seems to load down the audio source. It's an impedance problem, I believe. Never did figure it out. I was under time constraints. I'm not an expert. It worked good enough. But it would be nice if somebody could come along and kind of figure out what is wrong on the front end of this, the portion that takes that audio, that low-level audio input, and turns it into a voltage output for the diode ladder. If somebody could kind of figure out the correct component values. Now, the nice thing is, when I designed this PCB, I made sure to design it so that the input section is separate from the output section, from the, where the audio input signal comes in and then produces the voltage required by the diode ladder to actually fire the transistors in sequence. There's somebody out there that's a whole lot smarter than me that could figure it out and say, hey, switch this capacitor or omit this capacitor or add that capacitor or resistor or so on and so forth. Or the nice thing is just omit all of those components, make a small daughter board that could just kind of solder right in here with all the appropriate front end components to drive the actual driver section. Okay, that would be great. Nobody's ever done that. It's a flaw in the design, but it works. But like I said, on like an RCA output from a stereo, you will notice that it will actually load down that channel. Don't know what's going on, never figured it out, and I don't know enough about the problem to fix it. So that is what it is. Somebody out there, hey, go for it. That's the other thing. There is no proper. Years ago, I had one drawn out. Like I said, I kind of took some ideas from the internet, threw it all in a big old bowl, stirred it up, made it work. Okay, I had sort of proper semi-schematics I had written down on graph paper years ago, and they are lost to the ages. Somebody can sit here and reverse engineer this and come up with a proper schematic and forward it to me so I could share it with everybody. I would love that. I would even love a proper, input section to be designed so somebody could say, here, this is what you screwed up, here's how to fix it. Great. So, okay, the other question is that somebody, Chris Wright, told me that currently the King Bright LEDs that we specify in the PDF, that they are back ordered for 12 weeks, and he's like, can I substitute them? Well, yes, with a, a but. But will it work? Will the forward voltages of your replacement ones and current draws and light outputs be identical to what I don't know. You'd have to try it, and the thing is trying it, you might end up with something that don't look right, and then you have a, fully populated, you'd have to unsolder all those things. Here's what I did. When I built the original, I made this setup, which I kind of refer to as a Christmas tree or a rocket. Basically, every one of these sets of lights indicates a sequence on the entire lip light PCB, okay? And what I did here is I have a bunch of resistors at the back and then adjustment trim pots underneath. And I had to go through and meticulously, I laid all these out so that the lights are in the exact positions, that they are in sequencing on the lip light board for any given any given one of the given 19 inputs, and then sat there and trim potted these things so that all of these LEDs were the exact same brightness. And then measured the resistance values and then found the closest possible resistor I could, standard resistor value I could, to make all of these things light up evenly. Okay, because at different currents, I kind of had to find a sweet spot. Because if you provide more current to a given set of LED lights in like a red, green, and orange, a higher current might mean that the green LEDs start to overtake in brightness the adjacent red ones. So I had a real kind of, I had to find all of the sequences to find their happy place, to make it all look right. This way I didn't have one set of string of LEDs that was much brighter than the LED string next to it. So there was a lot of give and take there, and it also had to be screen accurate. So, can you replace the LEDs with if you match up all the specs that they provide in the spec sheet with another brand's LED, then yeah, you'd probably be just fine. But different manufacturers, different lots of LEDs, they're all going to differ. That's the other thing. If you buy LEDs, I would suggest you buy all of them in the same lot, because different production runs are going to produce LEDs with slightly different, light output and current requirement characteristics. They're going to have a minimum and a maximum. That's why it's like when you try to paint a room in a house. You don't, you try to make sure to buy paint that's all from the same lot, from that same production run, because if you don't, if you wait a couple months, go back to the store, buy the same exact paint, and then start painting, you're going to have slightly different shades between the two lots of color. So I don't know if I've answered everybody's questions, but and I'm trying to remember as best I can what I did back in 2009 when I literally had to learn the electronics. I had to learn PCB layout software. It was just, I had to teach myself all of this, and I was under a time constraint because the lip light PCB that I had to get the actual measurements from was actually borrowed from a collector of that had a J5. I still don't say his name because he didn't want everybody to know that he had a J5. So, and the deal was that, hey, you send me that one so I can get the proper sequencing and dimensional information that I missed when I documented Eric Allard's. I will send you a modern replacement with LEDs, because again, the original one had incandescent LEDs. They were some sort of indicator lights. Actually, I have it here on my desktop. I'll pull it up and I'll minimize it here and slide it up to my top monitor so I can see it and see my video at the same time. They were a CM25 series T1 indicator. And they consisted of a panel mount base, a PC mount base, what's called a grain of wheat T1 lamp, and then like a polycarbonate cap that went onto them. And they're out of production many years ago. We just so happened years ago, somebody found this, and said, oh my God, that's what they use. Let's buy them. They don't manufacture them. I can't find them. I don't know what they were used in. If you look on the Facebook forums, or Facebook pages, the ones I want to customize my Johnny 5, and the other one's full-size replica, something or another. Look around on Facebook. You'll find them eventually. I posted up one there, but yeah, so they don't make them anymore. And even if they did, you would have to completely redesign the PCB. They were run in parallel. They were run with analog technology. We didn't have proper documentation of the actual driver circuit that they used. Just a couple quick photos I took. So yeah, you can't get them. The light bulbs were not, the indicator bases were not relampable. So when you blew out one of the lights, it was blown out. You would have to sit there and unsolder everything. And yeah, so we went, I decided, hey, LEDs, this is the way to go. And a lot of people, and a lot of people have said, why didn't you do it digitally? Use some sort of like bar graph driver display. I tried that. And if you look at my other videos, I couldn't get it to work. My own inability, I didn't know enough about electronics, and what I did try just wasn't, it didn't look right. It just didn't operate correctly. So this works good. It looks great. It replicates what they did on the original robot with the incandescent lamps. And I'm glad I actually looked at this PCB. The capacitors on the back of the board were put in afterward, okay? That's because when I did the original prototyping, I used an LM series voltage regulator. And when I got the actual 20 volt regulator, the circuit didn't work. And I was freaking out. What's going on? Oh my God. It doesn't work. And of course, I went through, I checked all my components, all my solder connections. It wasn't working. The only thing that was going on is that this indicator light was like quickly just blinking. So what I did is I went back and I went through the data sheet for this regulator, and as it turns out, the actual regulator itself required these capacitors to be put in there so that the regulator itself operated correctly. And that's why they're located on the bottom of the board. So that's why that sort of, oops, it doesn't work, dear God, can I make it work? That's why those are in there. And they're very small, very discreet. I mean, they don't interfere with anything, and they work out just fine. But they are, as it turns out, required. So there you go, folks. I hope I've answered some questions. Again, feel free, yeah, by all means, make a schematic of the circuit that I've done, and then provide, if you have the expertise to figure out, hey, this is where Terry screwed up on the original, here's how it can be either adapted on the board itself, or we got to get rid of all these components and just slap a daughter board in there to operate, correctly, so it doesn't load down the audio input signal, which, I don't know what effect that would have. I didn't burn anything out. I was using an old boom box, the RCA outputs from an old boom box, the audio output from the PC. I ran both. I never had any problems with it. And I should note that, since I'm thinking about it, there are technically 3 adjustments. So the actual audio output level that you're inputting into the board, so that volume adjustment, if you will, and then the 2 potentiometers on here. So all 3 of them actually get dialed in to adjust the lip lights so that they operate properly. It's kind of a pain, but once you've got it set, once you have the potentiometers set, you have them set. So there you go. I hope that clarifies some things. I'm sorry the video is long-winded, but I talk a lot. So yeah, by all means, make a schematic. The only thing I would ask is, people have said, oh, could you supply me with Gerber files of this PCB layout? Respectfully, no. Folks, I'm not asking this much, that much money for these things. The people in the UK kind of get screwed because the shipping it's $35.25 for shipping for a priority mail box from the United States to overseas. So that is what it is. I can't control that. Here in the U.S., the shipping cost is very minimal, but I ship them in a priority mailbox. I include the connector and the regulator, so the black connector and the regulator. I throw them in because it's kind of hard to buy just one of them. And the regulators, I actually at the time had a difficult time even locating them, and I had to buy like 50 or 100 of them. And of course, if you bought one lip light PCB, you only need one of each. So I throw them in there, but the rest of the parts you have to supply. They're just off-the-shelf components. But the back order on the King Bright lip or LEDs, you know, there's nothing I can do about it. I would say if you want to make sure, absolutely sure that it works as intended, get the actual parts specified in the PDF that we, you know, supply. Use the actual components. But if you're really good at electronics and you're like, no, I know what's going on, you know, I can change the resistor values to accommodate any issues that come up with the a different manufacturer of the LEDs, then by all means go ahead and do it. Now, with that being said, I should add this. If you operate all the LEDs, the entire, you know, if you fire all these up at once and keep them fully illuminated, like full on, things are going to get warm. Okay? It really isn't intended to operate in that mode. These resistors in here, some of them, depending upon the string, they're going to get pretty toasty. But you should be okay. The regulator will put out the current. I think the maximum current draw on this thing with all the LEDs lit continuously on is 0.5 amp. And the regulator, I'd throw a heat sink on if you're going to do that. The regulator will start getting hot, and so will some of the resistors in there on some of the strings. So there you go, folks. Hope that helps out. Hope that kind of clarifies things. Again, sorry for the long-winded nature of the video, but yeah, there you go. So Terry Andrews Jr., J5 Guru, signing out, saying bye for now. And the monkey pushes the icon.